Right, so this is again our final one, and I would say probably the easiest unit for measurement is calculating your volume. Okay, because if you're able to calculate the area of any shape, you can calculate its volume as well. And our intention today is to be able to obviously calculate the volumes of prisms, your cylinders, and your composite solids. Okay, so prisms, cylinders, and composite solids. Prisms are like your triangular prism, rectangular prism. Cylinders, we all know what that is, and your composite solids are shapes where they're just put together. Okay, and in terms of your success criteria, we're going to be able to obviously convert between units of volume, calculate different volumes of prisms, cylinders, and your composite solids. Okay, so that's what we're going to focus on today. Hopefully, this will be pretty straightforward for you guys. Okay, so let's start off with a really quick activity. Here we have a cube called Rosie's Cube, and you probably all have come across this before. Okay, for a cube like this, we can see that it's made up of a lot of tiny little cubes. Okay, so let's do some discussions on this. How many cubes, can anyone tell me, how many cubes do you think you might need to fill up the rest of this space? Well, no, anyone calculate how many cubes? So the basic principle for volume is basically the shape or the space inside a certain shape. Okay. Now for this, there's other ways you could calculate it. Like for example, I can see that this cube has a height of about 4 cubes, a length here of about 5, and then this length over here is also 5. So if you wanted to calculate how many cubes there are altogether, you would go 5 times 5 times 4, which equals 100. Okay, and then from there you could figure out, all right, if all of it equals 100, how much do I need to fill up the rest here? And then you could figure out what the shape is there. But let's continue on. So the idea behind volume is basically the space inside certain shapes or certain 3D shapes. So these are the shapes that we're going to be looking at: your triangular prisms, your rectangular prisms, your cubes, and these shapes here. We probably won't really be looking at your pentagon and hexagonal prisms, but mainly these four. So triangular prism, rectangular prism, cubes, and all composite shapes like this. Okay. And again, our intention is to try and solve, okay, the volumes in these shapes. Right, so again, what's volume? Volume is let's go to the next slide, which is slide number 31. So what's volume? It's basically the space within, okay, a 3D shape, three-dimensional object. That's the main thing you're going to look at. Volume is a space within a 3D shape. That's all volume is. Space within a 3D shape. You can actually measure volume based on these three measurements, okay? But the main ones you'll probably see are centimeters cubed, meters cubed, or millimeters cubed. I don't know why it's not mentioned there, but those are the three that you'll probably see. Well, you won't really see demimeters, but sometimes you might. Okay, but most of the ones you'll see, centimeters cubed, millimeters cubed, and meters cubed. Also, you can sometimes you'll come across a problem where if you have a shape like this, like a meters cubed, how much liters can you fit in that? Or if you have a shape that has this many millimeters cubed, how much milliliters can you fit in that? Okay, this table here is a little bit confusing, okay, but I'll try to explain it. What it's saying is 1 millimeter is equal to 1 centimeter cubed, or 1 millimeter is equal to 1 demimeter cubed, or 1 millimeter is equal to, 0.0001 meters cubed. Basically, what I want you to understand here is that you can actually interchange milliliters into centimeters, or vice versa, okay? And the way we do that, okay, and I want you to write this down somewhere, 1 centimeters cubed, so if you have centimeters cubed, is actually equal to milliliters cubed, whatever it is in milliliters. So for example, if you have 10 centimeters cubed, centimeters, it's equal to 10 milliliters cubed as well. Milliliters, you don't need the cube, sorry. Alright, so that's what that's saying. 10 centimeters is equal to 10 millimeters. When it comes to meters, however, 1 meter, so like a 1 meter cube, so 1 meter cubed is equal to 1,000 liters. Okay, so just some things to think about. 1 meter is equal to 1,000 liters. So if it's a meter cubed, it's equal to 1,000 liters. Also, you can think of it as 1 meter cubed is also equal to, if I multiply that by 10, so 10,000 mils as well. But the main things that you want to actually look for is that when it comes to centimeters cubed, okay, it's actually equal to milliliters. And when it comes to meters, you'll normally be asked to convert it into liters. So if you have, for example, 2 meters cubed, okay, that'll become 2,000 liters. And in terms of conversion, so if you want to convert, so maybe centimeters to milliliters. So if you want to convert centimeters to milliliters, it's going to be just 1 for 1. You're going to just times it by 1. You don't need to do too much. Okay, just because it's the same. But if you're going to convert meters cubed to liters, it's going to be times by 1,000. Okay, just these are the two main things that you just need to keep in mind. Okay, so if you're going to convert centimeters to milliliters, it's times by 1 because it's the same. But if you're going to convert meters into liters, you have to times it by 1,000. So let's say, for example, I have 3.21 meters cubed. Cubed. What does that equal in liters? Well, if you times it by 1,000, it equals 3,201 liters. Okay, that's how much it will be converted to. You'll only come across this question once, I remember, in the SAC, so it's not really that big of a deal if you don't get it. But the main thing is these two principles here that you need to really think about. How to convert centimeters or meters into milliliters or into liters. Okay, let's keep going. Again, visualizing volumes, this is similar to what we did here. Okay, so we'll just skip that for now. And some other conversion units. Sometimes, I don't think you really come across this too much, but when it comes to liters, you can see that all of it is just either going to be multiplying by 1,000 or dividing by 1,000. So it's all the same amount. So let's say, for example, I have 23 megaliters. Okay, so I'll get 23 megaliters. How do I convert that into liters? Or according to this, it's going to be times by 1,000 and then times by 1,000. So it's going to be 23 megaliters times by 1,000 and then times by 1,000 again. So that equals to 23 million. 23 million liters. Okay, and it's the same way the other way. If you go back to milliliters to like kiloliters, just make a note that it's divided by 1,000. Okay, so won't go through too much of this because again, there's not a lot of this that we do for measurement. You may come across 1 or 2 questions of it. Same thing with cubic meters. Okay, if you're converting between meters, decimeters, centimeters, millimeters, okay, it's going to be times by 1,000 or divided by 1,000. It's all the same amount. Okay. Let's get into some actual problems. So let's go, actually, really quickly. If you think about some oblique shapes as well, or oblique prism. So an oblique prism is something that looks like this, okay, where it looks like a rectangular prism, but it's kind of slanted, okay. Hands up if you think, actually, what do you guys think might happen to the volume of the shape as it gets more and more slanted? Any idea? What would happen to the volume as it gets more and more slanted? Probably less, right? Because what's happening inside? Okay, the area inside the shape is actually getting smaller and smaller as you go. Okay, why that happens is because obviously the height of the shape actually changes. So if you look at the height initially, it's 10, but as it slants, the height will eventually start to decrease. Okay, so this might just become 8, and then the height here eventually might be 6. Okay, so you can see that the volume, as the slantier a shape gets, the less the volume inside. Okay. All right, let's keep going. So let's go to calculating some of this. Volume is really, really easy. Okay, the basic principle of it is all you got to do is find the area of it and then multiply it by its height. That's all it is. Find the area of one face, multiply it by the height. Or you can say find the area of the base, which is basically the face there, and then you multiply it with its height. That's all volume is. It's really, really simple. So for example, if I have a cylinder here, if I found the area and it was like, I don't know, 4 centimeters squared, and the height here was like 3, well, therefore the volume of it will be 4 times 3, which equals 12 centimeters cubed. Okay, so the principle is find the area of the base or the face and then multiply it with the height right here. That's for any shape where you're trying to find the volume. Okay, and that's what that's saying there. So let's do some of these examples. Okay, so anyone remember the area of a parallelogram? Parallelogram. So for a shape like this, area of the parallelogram. So I can see that for this I've got a length of 7, okay, and I've got a height of 3.5. So for a parallelogram, it's going to be length times height. So if I find the area of this and then multiply it with the area of, or the length of this, okay, I can find its volume. So for this, it's going to be, the volume of it will be volume is equal to length times height, and then maybe, I don't know what you want to call that, we can call that the width if you want. Okay, so this is going to be 7 times 3.5, and then times that by 8. Okay, and then that'll be 7 times 3.5 times 8 equals 196. So the volume is 196 centimeters cubed. Alright, so really straightforward. It's all again about just finding the area of the face and then multiply it with that length or the height or the width or whatever it is. Some people also think of a volume as just multiplying all the numbers together. You can also think of it that way. It also works. But just make sure you multiply the correct numbers. So for the volume of the cylinder here, it's going to be volume of the face, so pi times radius squared, so this area, and then times that by the height, which is that. So in this case, it's going to be pi times 2 squared times 1.5. Okay, so on my calculator, when I do that, pi times 2 squared, and then times that by its height. Again, pretty straightforward, 18.85. It's about finding the area of the base or one face and then multiply it with that height. So this is all in cubed. If I ask you guys, what would this be in milliliters? How do we convert it? Milliliters, centimeters to milliliters, not millimeters, milliliters. Yeah, 18.85, it's the same thing. Okay, so remember, sometimes you get a question where it says, all right, how much water can you fit in this shape? Well, again, just understanding how we convert units Okay, so there, centimeters to milliliters is just 1 for 1. It's the same thing. Here you don't have to change anything. So just again, you might come across a question where you'll need to refer to this. Okay, let's keep going. Composite shapes, straightforward again. It's just about finding the volumes of each shape separately, then adding them together. So if I broke this up into 2 parts, the cylinder at the top, okay, will have a, I can see that the diameter of it will be 6, so that means the radius is 3, and the height, according to this, is 2. Okay, so that's the first part. And then the rectangle in the bottom, or the rectangular prism on the bottom, okay, I don't have to worry about minusing any areas, because this is not about area, okay, this is about volume. I'm just finding the space within that shape. So for that rectangular prism, I can see that these lengths are all 6. The height is 2, and that's all I need to know. Okay, so height is 2, and this is a 6 by 6. So therefore the volume, so for the cylinder, the volume again would be pi times radius squared times the height. So it would be pi times 3 squared times 2. So on my calculator, pi times 3 squared times 2, which equals 56.55. And for the rectangular prism down here, okay, remember for it, it's just going to be length times width times height. Or in other words, you're just multiplying all the numbers. So it's going to be 6 times 6 times 2, which equals 72. And then when you add them together, so put them all together, 72 plus 56 equals 100 and 128.55. What's the measurement there? Centimeters cubed. All right, pretty straightforward. Okay, you're just going to add them all. I find that with composite shapes, it's really easy. Just find, again, separate them. Find the area of volume of one, find the volume of the other, and then just add them together. Really easy. And I think that might be it. Yeah, that's basically it for volume. Straightforward. All right, so again, just to recap, for volume, you're just finding the space within the shape. And to do that, you find the area of the face, multiply it with the height. Okay, and that's it.